Hello, my name is Sam, and in this video I want to share 4 examples of implicit bias that I have encountered. And I hope that providing these examples gives you some ideas of what to look out for. So let's get started. Number 1, most of the names in one of my data sets most of the names are mostly male. We did some exploratory analysis, and a simple bar chart with the most common names showed that they were mostly male names. This is a good example of a proxy for gender. As I said in the previous video, many times you don't get gender data. And this is not precise by any means, but using name as a proxy still gives you some valuable insights. So let's dig deep. What is this model going to be used for? In my case, I'm training this model to identify duplicate profiles. So gender shouldn't be a problem, but I really don't have enough information to make a firm conclusion. But what I will do is during validation testing, I'll take a quick look at the results and see if they skew male or female. So moving on, next example. So next bias I incurred is that most of the names I was looking at were American. Again, at first glance, you might brush this off as irrelevant, but I would caution against that thinking. So if my data set is mostly American and my application is mostly used by Americans, this might not be a problem. But I already know that I have European users. So how's it going to perform on that data set? Not sure. So now I have to think about maybe, what are the differences between American names and European names? Through my past experience in Europe, I know that they seem to have more names that are like the same but have a male and female version, like Michelle and Michelle. So if my model is trained on American names where the male and female names are more distinct, my model might not be able to perform well with European names. And that's just one example that I know of. I'm sure there's lots of other cultural differences that I don't know about. But speaking of culture, even if we only have American users, there are still lots of people in America with names from other parts of the world. I think in my data set, I only had a handful of Chinese names and a handful of Indian names, or at least ones I could recognize. There's probably other ones that I couldn't recognize. But regardless, I know that in my data set, it's heavily skewed. So that cultural bias might be there as well. And just like the first example, since I know this about my data, I can check this at the validation step and see if the model performs poorly with different names. Next up, zip code. This one is a big one. In the US, your zip code is highly correlated with your success. If you are from an affluent neighborhood, then you went to good schools that prepared you for college, that got you good jobs. and some people might argue that this is a good bias, that of course you want to hire people who are well educated and have the best skills. The problem with that when it comes to AI is that the AI model will only perpetuate that bias even more. It will make it even more extreme. And if people make hiring decisions based off of these types of models, then these poor communities will never get a chance to succeed. And it'll be an endless feedback loop. But for me, my model is not making hiring predictions. But I am in this domain, so I have to be very careful about what data I use and how it is trained, and who else will be using my model and for what purpose. And lastly, age. So, we generally don't get age in our data sets, but we have graduation year, and that is a good proxy for age. Age discrimination is a real thing, and just like zip code, our AI models can perpetuate that type of social discrimination. And this discrimination can happen on both sides. Somebody with a graduation year from a while ago might be too old, but also somebody who went back to school might be incorrectly classified as too young. So this can be problematic. But if your use case is similar to mine, you can use feature engineering. So for my example, I'm trying to identify duplicate profiles. So I might engineer a new feature that is just a Boolean, true, false, if the graduation year is the same. No number, just true, false. So in that way, the model doesn't learn the bias that comes with age, but it's still using it for uh, to as a feature to predict whether or not two profiles are the same. Um, that might be unnecessary. I might be overthinking it a little bit. But again, this is something that I can check at the very end and see if there is any sort of age discrimination in my model. So, and that's it. I want to end with the same quote from last time. Bias is a systematic problem, so there's no silver bullet. And as with all my examples, the only thing that I think I can do is look out for bias or just be on the lookout for bias. Um, I hope this helps. Listening to other people's experiences has helped me, so I hope that my experiences can help you. Uh, but what about you guys? Have you encountered any bias in your data? Please leave a comment. Thank you for watching. I'll see you guys next time.